payload. So this is just an introduction topic. Okay, in itself we are actually going to start in probably in July or August a GIS topic. Okay, which actually will have a 5-day session. It's a online session, 5-day online session, where we are going to teach in depth about the data what you take out from the drone. Okay, probably we'll be teaching one of the GIS software also. Okay, so that is how it will be. This is just an introduction where it gives an idea what you can do using the drone data and what kind of analysis can be done in the future. Yeah, any questions?
No, sir.
Okay. Okay, so when you say drone data, means what data we are actually talking about? Do you have any idea what data we are talking about over here? Since you have attached the RGB cameras, you have attached the thermal camera, you may have attached LiDAR, or you may have attached your multispectral, hyperspectral cameras. These will generate lot of data. If you take about example of a simple RGB camera, you are taking a photograph. Like if I am taking a photograph of a power line tower, okay, we did a project in 2023 for Bihar Power Board, okay, in that where we were actually flying the drones and we were capturing the data about the towers. Okay, so we right from the base of the tower till the top of the tower where the wires are getting connected, the insulator, everything we used to capture using the drones. So when we capture those images, we need to analyze those images and find out if there is any faults or any anomalies. Okay, so there were actually known around 15 to 20 anomalies or faults. Okay, it could be like sometimes, since in those areas, the theft was a lot of challenges. People used to climb those towers and remove the metal bars for selling. Okay, so there were people who was doing this. So they used to remove the nut bolts and they used to cause lot of damages. So we have to put, board has to put a barbed wire around those towers. Okay, they have to put number plate was missing. A lot of time people used to theft those number plates because it's a metal plate. Okay, so it was easily you can take those number plate and sell it in a scrap. Okay, and you can get some money out of it. So people used to do all those kind of theft activities and all those things in those areas. So you have to fix or you have to weld. Normally you can't nut bolt those number plates and all those things. So later on they start putting welding. Okay, so they used to make it fix the number plate on the number plate or the danger plate on the power line towers and all the things. So we have to capture the images around the tower and see if there is any kind of like number plate missing, danger plate missing, member bar missing, nut bolt missing, insulator getting faulty. There could be a bird nest been created on the towers, or near the power line towers, that would cause some kind of a short circuit, or sometimes birds used to get depopulated. Even these towers were subject to monkeys. So a lot of monkeys used to make their houses on those towers and all the things. So you have to put some kind of a barbed wires or some mechanism so that monkeys also don't stay on those things and all the things. You have to drive away those monkeys from those towers and all the things. So there were anomalies, all these things you have to find out. But then once you have this data set, this is all manual work. So we did only a project for 100 towers. Okay, so our project was more or less a period of like 1 year. Okay, we took 1 year to complete that POC itself. Whereas the real project was about for 12,000 towers. It was about 16,000 kilometer of area or lines. Okay, power lines. So there were almost 12,000 towers were there, which needs to be monitored using drones. So this was initially a POC kind of a project where board want to understand whether they can do or it will be beneficial for them to do the drone monitoring kind of or drone surveillance. So traditionally they used to do earlier is that there was a person, one or two persons used to visit these towers. They used to take DSLR cameras and binoculars. Okay, so on the ground itself they used to stand, and at the angle they used to shoot using maybe a zoom lens or something. They used to capture the images, they will come back, then they will analyze and all the things. So this was very tedious and not of what we say sure shot monitoring kind of thing, and you are not getting a right results, not right inputs, or the amount of data what used to capture was very limited. Okay, so when I was flying the drone or my pilot was flying the drones around those power line towers, they used to get almost, like initially they used to get around 200, 300 photographs. They used to get video footages of almost 1 or 2 GPs of that. Okay, but then that itself during that manual flying of the drones was again a challenging for us. So when we did the first set of 10, 15 towers, then we realized that manual flying around this tower is not a right way of doing it. We need to do some kind of automation to fly, because every pilot who is flying the drone was his own way of flying the drone. Okay, so the data what was captured by these pilots was not uniform, not structured. So we saw these challenges in the first trial run, and then we approached one of the company who helped us to define the flight plan. Okay, so which helps us to fly a drone around the tower in a proper sequence. So drone used to take off, it will start from the base, it will go up till the top, it will capture, then it will go to the other side, because it's a square structure, right? It's a square structure, so it has 4 sides. The tower will always have a 4 sides. So one side it will capture, go up, then it will go other side, it will capture, it will come down, again it will go on other side, it will capture, it will go up, again it will go to the other side, it will capture and come down. So that's how it captures all the 4 sides of the tower, and that's how I used to get a very uniform images of entire area of the tower. Okay, then it has to capture the video footage of the tower. So normally it will start again from this position, and in a spiral way it will capture. Okay, with a uniform distance away, because as you see the base is much bigger for the power line towers, but as you go upper and up it becomes taper, right? So normally you have to fly, because normally when the drone is flown manually, the pilot doesn't have a uniform distance from the tower range. So we fix that distance, that you have to fly 5 meters away from the tower. So at the base it will have a bigger circle, but as it closes, as it reaches top, it is maintaining that uniform structure. So I can really see, if I when I was seeing the video footages, I can see the tower in a proper angle. I can get the input, so I can correlate the videos as well as the photos to see what I am seeing in the images. But again, that was a manual task. So later on, once we did almost 20-25 towers, and when we are doing analysis of this images, the video images as well as the photographs, we saw that it was very difficult, because manually when we were taking the photographs, we were getting around 200, 300 photos. But when we started doing the flight plan and all the things, we were capturing almost more than 500 photos. 500 to 700 photos was captured. Video size was almost like 2 GB, 3 GB, up to 5 GB, depending upon the type of tower and how big the tower is there. Okay, so depending on that, how many flights I have done on the tower, the amount of data was huge. So doing manually analysis of those images was very difficult. So we have to use AI ML to develop a software where we can analyze those images. We have to train that ML software, the machine learning, to analyze those images and find out those anomalies. It could be danger plate missing, number plate missing, barbed wire missing, or maybe vegetation plantation around the basement of the towers, bird nest, insulator broken, faulty, damaged, missing, nut bolt missing, all those member bar missing, support member bar missing, all those things were there. Oxidization near the wires, where the two wires are joining and there is an insulator on the top. That point of time where lot of time the what is that, spark happens, and it burns the insulators or it damages the insulators. Wire also gets oxidized and all the things. So heating of the wires also causes lot of oxidation on the wire. So all those images were there captured, and you need to analyze. So manually it was very, very difficult for a human to analyze 700 photos. Okay, so that's why we designed a software along with one of the software company, to analyze this AI ML. So we used one of the AI ML, AI company which was working on this kind of a software, and we helped them to give the data inputs. We helped them to train the software so that the moment I put the 700 photos, the videos, and whatever is required, and within around 10 minutes to 15 minutes, I used to get the complete report. So I used to get those photos marked on the data in a form of a PDF or a reporting structure where it says, okay, this particular number of name of the photo, you will see, this kind of a problem. On that photo also, those markings were there, so that they automatically all these things were done without human intervention. Initially, our AI software was able to find out anomalies around somewhere around 55%, 60%. But later on, as we did give more and more data, we trained that software. Okay, we were able to achieve around 90% of efficiency. Okay, so it was able to find out those anomalies, whatever we have defined or whatever we have trained, but it cannot reach 100%. Okay, lot of time the software was giving even sometimes false, because the images what was taken, like example, area where there was supposed to be a bolt, okay, nut bolt was supposed to be there, but when you take the image, sometimes that area where supposed to be a bolt supposed to be there, you will see that there is a bolt, okay, because of the shadow, okay, or maybe the way the image is been taken, or during what time the image has been taken. So you will normally see this, like, or sometimes bolt is there, but normally the software will think that bolt is not there because of the way the image has been captured. Okay, so you normally missing bolt will always have a darker area over there. Okay, or maybe sometimes bolt where the bolt is there, but it will look dark because the way the image has been shot or what time the image is shot. So the lighting effect, okay, during the sunrise, during the sunset, or during the overhead sun, what time the image is taken, that image will differ. Okay, so a lot of times some false images were also been defined as a errors or anomalies. So this was actually a wrong information. So that's why we're saying we never reached 100% because of type of the image what we capture. So this topic is talking about the same introduction to drone data and analysis. Overview it is giving you about what could be the parameters helpful for doing the drone data analysis. Okay. So what is the table of content of this topic is principles of observation. As I said, when we are observing means we are actually capturing the photographs. We are capturing the data. So when you are seeing those photographs, as a human, what do you interpret? You can interpret based on the shape. You can interpret based on the color. You can interpret based on the shadow. You can interpret based on the patterns. You can interpret based on the tone of the image. All that aspects. What is the elements what you require for image? So principles of observation, elements of image and video interpretation. Then we talk about introduction to photogrammetry, because earlier this traditional way, like even before digital DSLRs, okay, before DSLRs, they used to use film cameras to capture the image. So they used to shoot the images, they used to come back, process those images, and create photographs. So they have, when we were initially having the meetings with those board, they showed those earlier inputs also. They showed us some photographs. They showed us what was wrong in the photographs. So that helped us to understand the requirement. Okay. So we were not aware because we were not from the power line board industry, but we were from the drone industry. So we wanted to see how drone can be useful, or what is that they are looking for, and how we can fine tune or how we can make use of drone for their current day-to-day activity. Okay, so when they showed us their data, they showed us their way of doing things. We also visited with them and understand and see the towers, how they think. So we have to understand their psychology. Okay, we have to see how they are working, or how they are interpreting, or how they are getting the data, what they were actually looking. So over the period of 3 months of period, we understood their operational activities and all the things, and then we aligned ourselves, and we saw that how this drone can be helpful for their day-to-day activity. Okay. So recognizing target is the key interpretation of and the information extraction. So whenever you have an image in front of you, you need to interpret the data from it. Like I show you the thermal image of the pipeline. Okay, so when you see and when you show it to somebody, nobody will able to interpret or extract information from it until unless I tell him, like I told you that where the pipe was normal, where the pipe was having issues, or what could be the issues or what could be the future challenges, then only. So you need to train people for recognizing the target and interpret and extract information from your images. So that is your principle of observation. Observing the difference between the target and their background involves comparing different targets based on any or all of the visual elements of tone, shape, size, pattern, texture, shadow, and association. So a lot of time we can always have two images. Okay, in earlier days they used to have two photographs, a normal photograph and the issue photograph, and they used to compare. So there is a device called as blinkometer. Okay, so you keep both photos are being illuminated by the light, and there is a switch, a toggle switch. So when you toggle it, one light will go off, other light will come off, one light will come off, another light will go off. So that way you will able to see one image at a time. So when you are doing it this using blinkometer, what happens, the difference or the missing point or anything new is has come up into the image will appear in front of you. Okay, that is how in olden days people used to, in astronomy, if you see the example, how these planets were formed or comets were formed, how they used to found, like they used to take the images of the sky every day. So every day when you are seeing the image, you used to compare, the image of the same set of the sky over the period of 30 days, years, and that's how you see that, you will see the same pattern of stars. And when you see there is a some particular object has moved from one location to another location from a point of view, you will see that, and then they will have series of more information available. That is how they used to confirm that it may be a object, maybe a planet, or maybe a comet. So similarly, when we see these two images, we find the differences, okay, by using the blinkometers. Okay, so that is a very traditional way of doing it. But now, because of the technology advancement and new AI, ML, all these things are available, we can always use those software to do that analysis. So whether it is a tone, shape, size, pattern, texture, shadow, and association with respect to the images, we can find out the difference in the image itself. Okay. So tone is basically a relative brightness. Okay, it will help you to give the color, brightness or color of the object in an image. Generally, tone is a fundamental element for distinguishing between two different target of features or images. Okay, variation in tone also allows the element of shape, texture, and pattern of object to be distinguished. So I told you the if you have a two different images of a particular object, and you can find out the difference around with respect to the tone. Okay, similarly, if you see the shape, okay, like if you see this here shape, that refers to the general form, structure, or an outline individual object. Shape can be a very distinctive clue for interpretation. Straight edges, shapes typically represents urban or agricultural field targets, while the natural features such as forest edges are generally more irregular. So if I am having a very structured shape in the images, I can see, okay, this is the field or maybe a agriculture field. But a forest area will not have a very structured shape. Okay, it will be very irregular. So that's how I can, okay, this may be a forest or a vegetation which is not grown as a crop or anything. It is just a wild vegetation would have grown at that particular location. So those will be normally irregular in shape. Okay, except where the man has created a road or a clear cut walking areas would be there, farm or crop land irrigating for rotating sprinklers would appear as a proper circular shapes. Like here you can see a structure in the thing, it's a circular, maybe this could be a jogging track or recreational lands would be there. Here also you can see there is a elliptical circle is there, okay, which represents some kind of a jogging track or maybe or some area which could be held for recreational, or maybe a playground could be there. Okay, then patterns, okay, refers to the spatial arrangement of the visible discernible object, typically orderly repetition of similar tones and textures will produce a distinct and ultimately recognizable pattern. Maybe orchid trees, okay, space trees, or urban streets with regular spaced out, like you have built a huge colony of similar type of houses. That picture will give you a repetitive patterns. Like if you see an image of a Barcelona city, it will give a very similar type of patterns. Okay, the structure of the Barcelona city, the houses, the buildings, they are very unique structures, similar structures. So this will give you a patterns. Okay, so pattern also will give you a different type of inputs when you see those images. Okay, then the size. Okay, if you see these big images, you can see here there is a big house or a big warehouse is there, or else whereas you see on the left side a small house structures are there. So this could be a factory area or maybe a warehouse area, and then some smaller offices are there in this particular segment. But you see on the other side of the road, you can see small house structures are there. This could be a residential complex, or the maybe people who are working inside this factory, their small houses could be there. So that's how, looking at the size, you can differentiate on the structure. Okay, you can make out the bigger structures and the smaller structures, and then you can see other features in the images, the roads, the trees, and all other things what is there in the particular image. Okay, texture, again we talk about the texture. Like you can see here, the trees are there, they are irregular in shape, their area is not very clear cut defined. Then you can see a barren land over here, then you can see some grassland or vegetations at the back of the trees and all the things. So you can see with respect to the texture arrangement a tonal variation in particular area of image. Rough texture would consist of molted tone with a gray level of changes. So you can see smooth textures are often result of uniform even surface such as field, asphalt, or grassland. A target would be the rough surface or irregular structures such as forest canopy. Like you can see here, the forest canopy is there, right? This is all trees. Okay, texture is one of the important element for distinguishing feature in radar imagery. So this type of pictures you will see when you are capturing through the radar or the lidar, which is flown using satellite images earlier. Okay, so earlier lidar, which was used more or less for the remote sensing using the satellite technology, you will see this kind of images over the bigger picture of the when you are surveying a particular district. Okay, you will see this kind of images. Okay, again shadow, again depending upon what time you have taken that image, like whether you are during initial sunrise or maybe overhead or during the evening sunset time. Like when we are doing the power line towers, the when you take the images in the morning time, uh, uh, one or two sides used to come proper, other sides used to come darker. Okay, so we have to take the images at the different time zones or time levels. Like mornings, in morning slots we have to take some images, in the afternoon slots we have to take. So in the afternoon slot, which we called as a golden hour. Okay, so from 11 a.m. till 2 p.m., when the sun was overhead, during that 2-3 hours of time, we used to get a very good illuminated image of the tower, because it was illuminated from all the four sides. But during the sunrise, okay, during morning time, 7 a.m. till 11 a.m., when the sun was at an angle, so only one particular side of the tower was illuminated, whereas other side was not able to capture because our camera was facing the sun. So sunlight was actually blocking the visibility of that. So when I'm facing my back to the sun, I was able to get much better image of the tower. But when I'm facing the sun, I was getting darker images. So that was not good. So I used to capture at a different time of day the images of the tower during the sunrise, during the overhead the sun, and during the sunset period. So different time of day I used to capture the images for all the four sides of the tower. So that's how, because shadow was impacting, the darkness and all the things was impacting my quality of images at different angles. So sometimes this shadow was helpful, sometimes it is creating a false reporting also. Like I gave you example about the bolt, right? So when the bolt is there, the shadow of the bolt was also dark, and missing of the bolt was also a dark. So the software was not able to interpret whether the bolt is there or not there. Okay, so sometimes lot of false reporting was also reported during the software usage for interpreting those images. Okay, so we have to really again, but at least out of 700 photos, we were only required to analyze around maybe 20, 25 or maximum 50 photos. Okay, where there was no anomalies in those images, those photos I really don't need to go and see again. But wherever it is, software was trying to find out the anomalies based on my definition. I used to only see around 50 photographs only. So I can spend that much time manually to come back and make sure assure. And that was helpful for me also to make or train the software more effectively. So my efficiency, as I told you, was around 50%, 60% initially. I improved the efficiency of the software to around 90%. Okay, that was possible, but I could not reach up to 100% because then I need more amount of data, more amount of right amount of photographs. Okay, so then only I can train. But then just by having the right amount of photographs or right type of photos for training was not possible, because every time that photo right amount right type of photos was not also possible to capture for the images. So that 10% variation will be always there in the software. Okay, my 100%, like I will give you an example of AI. Like I am training a AI model to identify apple. Okay, so I will show AI apple in a different angles, different lighting conditions. Okay, I will show it at least 10, 20, 100 types of apples. Okay, to make sure that it builds its database to understand and to identify the apple. But the moment I show a tomato, it will tell tomato is also apple. Okay, so I need to train for tomato also. So what is the difference between apple and tomato? So that's how I will make that. Initially when I was just showing the apple, my what is the accuracy was 50% only. Okay, because it can definitely recognize the apple, but when I am showing the tomato, it was trying to say tomato is also apple. So sometimes it is not able to recognize the tomato, or sometimes it was telling tomato is also an apple. So I have to train the software to recognize even the tomato and see the difference between apple and tomato. So that way I have to increase the accuracy of my software. Okay, so that is how I should do my data analysis and train my software to give me a better result. So by showing apple and tomato and making understand the difference, my AI ML software was able to give me, so it was able to give me sometimes a proper results. So maybe I was using around 80% of accuracy. So when I show apple, it was able to recognize apple. When I'm showing tomato, it was able to recognize that as a tomato only. Okay, every time I show variation, it was more or less it was trying to find out, but some places, one or two places, when apple was similar to tomato because of the color, very very reddish apple, or sometimes when the tomato was looking similar to the apple, that time there was a difference. So कभी कभी एप्पल को वो टोमेटो बोलता था और टोमेटो को कभी कभी एप्पल बोलता था. So that variation was there. Okay, so I cannot bring down that variation. Okay, because I do not know how to train it, because the way the software interprets the images, it has its own limitations also. Okay, we need to understand how our brain interprets the images and interprets. We know very clearly apple is apple and tomato is tomato, right? We never call apple as tomato, and we never call tomato as apple also, right? So our brain is very well trained to interpret, but that same interpretation what my brain is able to do, I cannot build it into the software. So that 10 or 20% variation was always there. Okay, so that is how. So we cannot achieve that 100% unless we come up with kind of algorithms or better understanding of computer science or AI ML features and technology. Then only we will able to interpret or make this. So that is what is about the topic on interest. So again, association. I told you association. Okay, if you see here association, you can see a watery area, the ships, okay, or the small boats are there. There is a ground for recreational activities here. There is a road over here. So you can see all those effects. So you can see this watery area. You can see some ships over here. There is a road. There are some structures around the road. Then you can see this recreational land is there. Okay, or maybe something. So that is how you can associate it, the photograph with respect to the ground or with respect to the background. Okay, so you can see here the watery body here and all that thing. So you can associate it around with it. Okay, so type of image and video data, it could be normal RGB camera images, infrared images, near infrared images, night vision images could be there, thermal images could be there, or could be a multispectral images also there. Okay, so I do not have any video data in this format as of now available, but you can see infrared images is there, or near infrared. You can see RGB image over here, and then you can see a near infrared image here. So NDV in for parameters you can make out, and you can find out the NDV value for a particular part of the image, and you can interpret the data. Okay, thermal images are there. We have seen during the payload or structure also. Roof, the side of the building, or the people standing. We can make out those thermal differences is actually helping us to generate the thermal images. Okay, or multispectral images also. Like we see here the NDV value. Higher the NDV value, that is the more cultivated farmland over here. Like if you see green, okay, 0.8 image it is showing. Okay, whereas the reddish is showing you 0.0035. Okay, so that is not a cultivated land, or it could be a barren land. Okay, empty land or half cultivated land, or where you have cultivated here land, it was having showing a value of 0.04. Okay, so that's how by looking at NDV values you can find out which part of the land or which part of the field is a complete grown field kind of thing, or which is ready to be harvested kind of thing. Okay, so that's how you come to know from the multispectral images. Normal RGB images will not give, it will just give a texture differences. You can see a green shape of the green, or darker green, or lighter green, or yellowish green you can see here images, or maybe a barren land also you can see here. Okay, but multispectral images can give you a clear cut differentiating in the field area. Okay, night vision basically gives you the night view of the particular location. And this is basically used in a military purposes or during the war scenarios and all those things. Okay, so basically that was the types of images. Now introduction to photogrammetry, because earlier photogrammetry was there. So I told you, like, there people used to take the hard copy of the photos and try to interpret the images and try to find the differences from the photographic products, okay, or the photographic images. Okay, so they used to create images, they used to make models using those images and all this. They used to create a 3D model also, okay, physical model also. But because of the digital photogrammetry, you really don't need to create any kind of a hard images or hard structures. Okay, so you in a digital photogrammetry, you can immediately analyze the photo. It was very simpler and less cost effective, and you can make a 3D model itself in a digital format. So okay, mapping from the aerial photography can take numerous forms and can employ either hard copy or a soft copy approaches also. Orthophotos combines the geometric utility of a map with the real world image information and provided by the photo. So you capture multiple photos and you can create a 3D model also out of it. The process of creating an orthophoto depends on existing reliable digital elevation model for the area being mapped. So more and more data, how much overlapping you are capturing. If you capture one image, then you capture the next image of the next surface. So you are not capturing the more better data. So if you are capturing overlapping, 80% overlapping, 80% overlapping. So you are having a set of data available with you. So that is where you can capture and make a real digital model from that. Okay, you can create an orthomorphic map with the elevation, with the texture, tonal differences. All that will give you a better clarity of the particular area where it is being mapped. Okay. So what you normally do during the drone data analysis, like when we captured all these images, okay, we were able to give you, like when we did the survey for 100 towers over the period of 3 months of time of the first phase, okay, we had some set of data. We found out that out of these 100 towers, almost 85 to 95 towers were having major issues, major issues. So we gave that data to the board, whatever issues were there, whatever the faults were there in those towers. So almost 95 towers, 85 to 95 towers were having major issues. Okay, after we gave that data, the board saw that data, they sat with their vendors, their support team and all that things, and started giving orders, started giving POs to the vendors to get those towers rectified with those faults, rectify those issues. Okay, so over the period of next 3 months, those vendors worked and got that, and then again the board told us to do the survey again. So again, this time, by the time that time we were utilized to do the building of the flight plan software and all that things. Okay, so we were actually also working parallelly because we had our own challenges also. Okay, because we initially did was manual activity, manual work, way of doing it. So it was not 100% accurate, not, and we know there were some challenges, some reports were not proper, and so we were working for getting our activity also streamlined. Okay, so we worked with the software company who helped us to build a proper flight plan, proper way of capturing data and all that thing. So in next 3 months, we used the flight plan, we used all the automations what we have done, we used those data and we were getting more accurate. So in next phase, when we flown the drone again on the same 100 towers, and as the OEMs vendors had worked on rectifying those issues and all things, we saw that there was a reduction from 85 to 95 towers to 55 towers or maybe 45 towers. So we saw the improvement. Even our data was not captured, was more reliable. So after again 3 months, further they was working, people were working, and after 3 months again we took the data. We saw that the tower were more healthier, more issue free. So almost it was around 15 to 10% only. So by the time of period of 1 year, when we completed our drone data analysis and flying of the drone, capturing the drone, and the data and the reports were generated, we saw that there were hardly 5 to 8 towers were only having a minor issues, not a major issues, because earlier these all these issues were encountered and there was lot of outages, power outages used to happen. Okay, which was resulting in lot of revenue loss to the board. Also because of these power outages, the area which was affected by the power outages, there also people were facing lot of revenue losses because 2 days, 3 days there was no power in those areas. Okay, so that people who are having industries, or people having small scale industries or work, even hotels were impacting, or restaurants were impacting, other businesses or other small scale people who are doing having businesses, those were also getting impacted because of the power outages. So not only the board which was impacting because of the outages and in the revenue loss, but the people which was affected by the loss of the power, they will also having revenue losses into their day-to-day thing activities and all the things, or they may have, and like this was a regular feature in that area. So a lot of people have deployed a small generators. Okay, but that generator was not giving them 100% power, or not power, because again it is expensive, right? They have to put diesel or the fuel into that, they have to run continuous. So but they were doing using those generator for bare minimum purposes only. Okay, so whatever you are doing a day-to-day business for maybe 8 hours, 10 hours, or maybe 15, 16 hours, you are doing business for a shorter period of time. Okay, so you know that power is not there, so you will shut your business for a time because you cannot continuously run the DG and that one. So that was a huge loss, not only for the board but the people also. Okay, but by doing this project for that particular area for those 100 towers, we were able to reduce the outages. Okay, we were able to reduce the outages almost to 5% to 10% only. Okay, so from because of 100 out of 100 towers, 85 towers were having issues and creating outages and all that things, we have reduced. And those outages or those problems were not because of the problems with us. There were different types of problems. Okay, different other problems which was not controlled by us or not captured by the drones. Okay, there were different areas where this particular outages were there. Okay, which was not relevant from the drone project itself. So those 5 or 10% of outages or 5 or 10% issues were there, was not directly impacting the revenue or something, but there were something minor issues were there. Okay, so that's how they saw the improvement in the providing the power to the region or power to the area, and making sure your revenue is 100% for that particular area of year. Okay, so they saw that okay, this was huge potential by using drone. So they said that okay, we will have a dedicated team, we'll purchase our own drones, we'll set up the entire infrastructure ecosystem so that we can monitor our all towers. Okay, maybe they wanted to build a platform, they want to build an app so that data can be generated in real time, and you can see historical data, you can get alerts and all that information. So whenever I used to see a software and see that data of that particular tower, I can tell the health of that tower. Okay, if there is a tower which is 100% error free, it will give me a green rating to that. Okay, a rating 5 rating was given to that tower. Okay, or 10 rating was given to that tower. Once if there is some issues or minor issues, maybe it will give a rating of 4. Okay, or the color of the tower may be changing from green to amber. Okay, or maybe yellow. Okay, or maybe maximum amount of issues are there, it will the tower color will change to red. So that means that is how you used to interpret, and you need to know in real time the problems on the particular towers. Okay, so those reports were also generated on weekly basis, monthly basis. Executive committee used to get the proper data about the health about the towers and the revenue generated, revenue losses because of the outages. All that was there, and they saw a drastic improvement in the functionality of the board. There was a good almost 15% of revenue improvement was there because there was less outages in the tower. Similarly, the example what I gave you about the water pipeline also. So as you monitor those water pipelines and you are able to reduce the outages because of the burst in the pipelines, reduce the outages of the water or affecting areas and all the things, you are able to provide error free water to the locations and areas because of the thermal drone flying and capturing the data and proactively taking the outages and controlling the burst and loss of water also. Okay, so that was very effective in that particular area. Okay, okay, so you can view the data, drone data in form of reports. You can export CSV, PDF, charts, graphics, tables. You can you can see a return of investment so that you can track efficiency, safety benefits, fix and program results, data mapping and navigation with the graphical user interface. So I told you, like they created a platform where like how you go into the Google Earth and you can zoom and see the images and all things. Similarly, they made a platform. They wanted to make a platform. They appointed one more software company which helped them to design that type of software, which can helpful for them to create a real-time 3D, 2D model. So they can just go and click on that digital platform and see the real-time the image of that particular tower. Give them the historical data. What was the condition of the tower 1 year back, 3 months, 6 months, 9 months, 12 months, and what is the current status of that particular. So they can see that historical data and interpret what is required so that they can keep their power line towers healthy. Okay, so that was what achieved by this particular project. So with that we complete the topic about drone data analysis. So this topic is just an introduction topic, as I said at the beginning of the session, whereas this gives you a complete idea that how much you can do in only, not only it is a flying of the drone, but the data what you capture from the data, how much you can do it, and what kind of industry, what kind of business model you can build around it, right? I told you about making a flight plan, successfully flying the drones so that you capture the right amount of the data, right type of a data. Okay, then you saw the utilization of the data what you capture from a perspective of what interpretation you are doing from the data, how you are interpreting, how you are generating, like AI ML what which was there. So there is, see, there are so much integration of the different segments, right? Power board is one. They incorporated the drone for their monitoring purposes. Now when you are getting the data, you are using AI ML. So much of other technology are tightly integrating by using the drone technology for all these activities. So power board, or maybe irrigation department where they are using drones for monitoring their pipelines over the period, or even the gas pipelines which flow from refineries to the location. So you can monitor all these things. Similarly, if you fly a drone for wildlife monitoring, conservation of wildlife, conservation of the natural resources, you can use drones for interpreting. You can see images, compare the images over the period of years or months or days also, and see the differences, what is happening, and how the natural resources are getting changed. Okay, so that is possible by doing drone data, flying the drone, capturing the drone data, and then doing the analysis. Okay, that is what is about the scripts or the summary of this particular topic. Okay, so with that we complete the all 11 modules required for our theory sessions. Okay, so any questions so far, anything you want to ask, or we are good to do a small run you through on the digital sky platform. Okay, so let me